now want to introduce three properties of logs that will be of assistance to us when we start solving logarithmic equations. So our first property is what we refer to as the product rule, which basically says if we have the log of two things multiplied together, like m times n, that we can break that up and take the log of the values separately and put a plus in between. So what that would mean in terms of an example would be if we had something like log base 2 of 5x, we could say to ourselves that the 5 and the x are multiplied together. So if it were easier for us to take the log of the terms separately, we could do log base 2 of 5, and then we could do log base 2 of x, and we could add the results. Our second property does basically the same thing, but it does it for fractions. So it says that if we've got the log of a fraction and we would rather not work with that fraction, we can break up the top and the bottom and separate them with a subtraction sign in between. So in this case, if we had an example where we had, say, log base 5 of x over 3, and we decided that it might be easier to not work with this problem in terms of a fraction, then I could take the log of the top part of the fraction, and I could take the log of the denominator of the fraction, and I could subtract the results. And then our final property is what we refer to as the power rule. This gives us a way to deal with exponents. And so this essentially says that if you're taking the log of something where you have an exponent, that you can take that exponent, in this case a p, and you can bring that p down to the front of the log. So as an example, if I were looking at the log of a log base 7 of, say, x to the 5th, then what I could do with that 5 is I could pull that to the front and then calculate log base 7 of x. So again, the third one just simply gives you a way to deal with the exponents in a logarithmic problem. So what we're going to look at in this section in terms of problems is we're going to practice these properties. So we're going to take a log expression, like what we have on the screen, and we're going to break it up using our properties. So this one says to write log base a of, and the quantity is x, times the square root of x squared plus 1 as a sum of logs. All right, so the first thing that I'm going to do is I'm going to notice that I have two terms that are multiplied together. Okay, I have an x that is one term, and I have this square root that's a second term. And so I know that I have a property that says that if I have two things that are multiplied together, that I can break it up and put a plus sign in between. So the one log will become two logs. So we'll have log base a of the first part, which would just be x. We'll put our plus sign in between, and then we'll have log base a of the second part. Now, you need to think through your properties. So we've just done the property for multiplication. Obviously, I don't see any fractions in this, so I'm not going to do the property for division. What I do, however, have are some exponents. Now, we want to be careful because the only exponent that we're allowed to pull to the front is an exponent that refers to the entire term. So in other words, this 2, this is not an exponent that I'm going to be able to pull to the front because that 2 only applies to the x. It doesn't apply to the 1 as well. All right, so what I'm going to do is I'm going to change out this radical. We know that a square root can be written as a 1/2 power. So I'm going to do that first. We talked about that in class, changing those square roots to exponents. So now I have an exponent that applies to the entire term, to the x squared plus 1. That exponent can be brought to the front. All right, so what I'm going to do is I am going to pull that 1/2 down to the front of the log. All right, so now we have log base a of x plus 1/2 log base a of x squared plus 1. All right, let's try another one. This one asks us to use the difference property to separate this logarithmic equation. So we have log base a, and then on the top part of the fraction we have x squared, and on the bottom part of the fraction we have x minus 1 to the third. So remember that we're allowed to take the 1 log and make it 2 logs, separating the numerator from the denominator of the fraction. And we're allowed to do that with a subtraction sign in between. So I'm going to take log base a of x squared, and then I'm going to take log base a of x minus 1 to the third. Now let's think about our exponents. So remember that an exponent that applies to the entire term can be brought down to the front. So what that means is that this 3 can definitely come down to the front. It also means that this 2 can come down to the front. Because that 2 applies to everything we just have an x, we can bring that 2 to the front as well. All right, so we have 2 times log base a of x minus 3 log base a of x minus 1. All right, so let's try one more of these. All right, so this one is probably the more complicated of the 3 problems. This time we want to use the sum and the difference formulas and the exponent formula to simplify this and break it up into a sum or difference of logs. So the first thing that I'm going to deal with is the fraction. And I choose to do the fraction first because the fraction is initially what I look at and think it's going to make it difficult. So let's go ahead and deal with the difficult part first. So I know that in terms of a fraction, I can make it 2 logs. So I'm going to make a log of the top part of the fraction. And then I'm going to put a subtraction sign, and then I'm going to do the log of the denominator of the fraction. All right, so the next thing I'm going to do is I'm going to notice that I have some multiplication happening. I have this term multiplied by this term. So let's go ahead and separate that multiplication. Remember that we can take that log and distribute it among those 2 terms and put a plus sign in between. So we're going to have log base a of x to the third plus log base a of the square root of x squared plus 1. And then I'm just going to recopy the rest of this on the right. Okay, so we know that a square root is a 1/2 power. So I'm going to go ahead and fix that down here before we do anything with the exponents. So I'm going to change that square root. It'll need to go in parentheses, and it's going to be raised to the 1/2 power. So then the final step is going to be moving our exponents to the front. Remember, as long as your exponent applies to the entire term, you can bring it to the front. So we can definitely take this 3 down to the front. We can take this 1/2 down to the front. And we can take this 4 down to the front. All right, and again, what I can't move is the x squared inside that middle term because that squared only applies to the x. and not the 1 or not the entire term. All right, so as our final answer, we have 3 log base a of x plus 1/2 log base a of x squared plus 1 minus 4 log base a of x minus 1. And actually, I'm seeing a mistake there. That minus 1 on the denominator was actually a plus. So let me fix that real quick. All right. Now, the other thing that we need to be able to do, we're talking here about taking one log and breaking it up into several logs. We want to be able to do the reverse as well. So we want to be able to take a problem like this, log base a of 7 plus 4 log base a of 3, and we want to be able to put it back together as a single log. So let me remind you on this problem that we previously worked, or on any of them really, the very last thing we did was move the exponents down. So if I'm going to reverse the procedure, the first thing that I want to do is deal with anything that might have been an exponent. So I'm looking at this 4, and because it's sitting in the front of the log, I'm thinking that it might have been an exponent in the beginning. So I'm going to move this back up and put it on an exponent on the 3. All right, so that's going to give me log base a of 7 plus log base a, and 3 to the 4th is going to be 3 times 3 times 3 times 3, that'll be 81. Now, if you notice, we have a plus in between. Remember on our properties, the plus signifies that it used to be multiplication. So I'm going to take these 2 logs and I'm going to merge them back into one log, and I'm going to do multiplication. So I'm going to do 7 times 81. And 7 times 81 is going to be 567. So our final answer will be log base a of 567. All right, let's try another one. Write the following as a single log. We have 2/3 log base a of 8 minus log base a of 3 to the 4th minus 8. Again, look for your exponents first. So my assumption is that this 2/3 used to be an exponent, and so I'm going to go ahead and move it up here on the 8. All right, so let's do a little calculator work now. I'm going to take in my calculator 8, and I'm going to raise it to the 2/3 power. All right, when you do that, 8 to the 2/3, you should get 4. I'm also going to go ahead and do some simplifying on the other term, the 3 to the 4th minus 81. 3 to the 4th is 81, and we're going to subtract off an 8, so that's going to leave me 73. So I'm going to place that here. Now, the only thing that's left is noting the subtraction in between and realizing that that causes a fraction to occur. So we're going to take our 2 logs, we're going to merge them into one log, and we're going to write our result as a fraction. So 4 over 73. So our final answer here would be log base a of 4 over 73. All right, and we'll try one more of these. All right, this one is a little more complicated. All right, so we're going to go ahead and kind of work from left to right on this thing. What I'm going to do is I'm going to deal with these first 2 log expressions first. So I look at that and I see log base a of x plus log base a of 9. So I know that if I have a plus, it used to be a multiplication. So I'm going to put these back together, log base a, and then I'm going to multiply the results. So we'll have 9x. All right, and then I'm just going to copy the rest. And then I'm sort of going to do the same thing. So I'm going to take the first 2 terms in this new expression, and I'm going to look at how I can combine those two terms. So again, I see a plus sign in between, and so I know that those two terms can be combined with multiplication. So I'm going to write down log base A, and then I'm going to put my multiplication. So basically I have 9x times x squared plus 1. And then I'm just going to copy the last term. So now finally I have two logs that I need to combine as one. Looking at what's in between the two logs, I see a subtraction, which I know means that I need to write a fraction when I put them back together. So I'm going to have log base A, and on the top I'm going to have 9x times x squared plus 1. And on the bottom I'm going to have 5. All right, so our final answer here would be log base A of 9x times x squared plus 1 divided by 5.